This lesson is about area, and area is the number of 1 by 1 unit squares that can fit into a two-dimensional shape. And there's a whole bunch of definitions here and formulas that we will refer to as we're doing the examples. The beauty of them is you have write in your book these formulas so that you can go back and forth as you're doing the problems. Let's take a look at number 1. Suppose a rectangle has a length of 5 inches and a width of 2 inches. The area would be 10 inches squared, or 10 square inches. And here's the representation. These are the number of 1 by 1 squares that can fit into this rectangle. So notice that I did divide them up into 10 equals 1 by 1 squares. So the area is 10 inches squared. And it makes sense that we say square inches because we're trying to fit squares into the object. So 5 times 2 is 10. Therefore, I didn't prove that the formula is length times width for the area of a rectangle. However, we're going to go with it. Here we go. Area is the length, which is 8.8 meters. And the width is 7 meters. So when I go to multiply those together, I will get 61.6. Now here's the cool part. Meters times meters is meters squared. So that's what that area is, 61.6 meters squared. So what does that mean? Well, I can fit 61 1 by 1 squares in there and 0.6 of another. Now, if we're going to find the area of this triangle, well, the area of the triangle is 1/2 the base times the height. The base of the triangle is 6 3/4 inches, and you can always find the height of the triangle because it makes a right angle with the base. So let's put the numbers in. 1/2 the base is 6 3/4 inches, and the height is 5 inches. Now, let's do this by hand as a review of fractions. So 1/2, I'm going to change this mixed to improper. So that's 27/4 times 5/1. So it can't cancel anything. So I'm going to do 27 times 5 times 1 is 135. Over 2 times 4 is 8. And 8 goes into 135. 16 7/8. But what are my units on this? Inches squared. How did I get the 7/8? I just did the division. And we have 7 left over. 16 7/8. Next, this is a trapezoid. A trapezoid has one set of parallel sides, and the other 2 sides are not parallel. So I wrote a squiggly line. The formula for that is 1/2 the height times base 1 plus base 2. The height connects the bases at right angles, and that's 6 yards. The bases are 3 yards and 7 yards. Now we'll add those yards together, and we get 1/2, 6 yards, 10 yards, Well, 1/2 times 6 is half of 6, which is 3 yards, times 10 yards, so we get 30 yards squared. You don't have to leave the units in the problem, but it just helps me remember that I need to do yards squared because they're not single units anymore. Now let's do circles. So the formula for area of a circle is pi r squared. So we need the radius. And in this case, the radius is 35 feet. So we need to square it. So you'll notice that you have to square 35, and that is 1, 2, 2, 5. And I also have to square the feet squared. So now my exact area, remember what we do for exact? We leave the symbol pi in the problem. 1, 2, 2, 5 pi, and then we label it with feet squared. And that is the exact. That means I'm not taking any approximations anywhere. So that's beautiful. Math people love this expression. For number 6, we're going to find the approximate area of the circle. We start out with the formula, and we need the radius. This entire thing is the diameter, and that is 14 inches. So we need the radius, which is the distance from the center to a point on the circle, and so that will be 7 inches because it's just half that distance. So the radius is 7 inches. Pop it into the problem. So it's going to be pi 49 inches squared. That is the exact area, which I was not asked for, but I'm just pointing it out. And now to get the approximate, I was asked to put in 22/7 for pi. So 49 times 22 over 7. Put the 49 over 1. 7 goes into 7 once. 7 goes into 49 7 times. And then I just multiply that out, and I get 154 inches squared, or square inches, for the approximation of the area of this circle. Last but not least, let's find the area of a compound shape. And in this case, it's a triangle and then a parallelogram that kind of looks like that. Okay, so let's get the area of the triangle, which is 1/2 base times height, and the area of the parallelogram is just base times height. So now we have all of our formulas in order. For the triangle, the base and the height come together at a right angle. And in this case, the height is actually a part of the triangle, which is fine. The base is 7 inches. The height is 6 inches. So we can multiply in any order we want. So I'm going to do 7 times 6, so 1/2 of 42 inches squared. And half of 42 is 21 inches squared. Now let's work on ye olde parallelogram. The area of a parallelogram is base times the height. Well, the base, since the top up here is 7, this bottom has to be 7 inches. So the base is 7 inches. The height is 10. That's a no-brainer. It's the only other value in the problem. 7 inches times 10 inches is 70 inches squared, so I can bring that right down. So my answer to the area of this compound shape is 91 inches squared. Now you're able to do the assignment associated with this lesson. Go for it.